Hello, physical science class. This is the video for our 18A notes that I'm going to make available to you. And I want to just kind of go through these quickly and make them not to be super long videos, just to give you the highlights of the chapter. So we're going to be talking in chapter 18 about bonding. This is building on stuff that we learned in the last chapter. So you're going to see a lot of the same, basic concepts moving on here. So the first slide here says that the arrangement and number of electrons in an atom determines how they bond. Okay, what we're going to see here is valence electrons are the things that are going to be bonding. The same element with the same electron structure can often bond in more than one arrangement. For example, graphite and diamonds are made of the same material, carbon, the same, basic structure, except they're organized in different ways. So graphite is very slippery, diamonds are very hard. Chemical bonds involve mainly valence electrons of an atom. So what we see in bonding is the outermost shell, the valence electrons. Remember in the last chapter we said that valence electrons determines the behavior or how an element is going to act. The octet rule is that most atoms are going to be the most stable when they have their full valence electrons. Remember though, there's that one exception to the rule, helium. Helium thinks that it's, and same thing with hydrogen. Both hydrogen and helium think that they have the perfect 8 because they have their full outermost shell of electrons, but they have nowhere near 8, right? Hydrogen only has 1 and helium has 2. Lithium, beryllium, and boron are also a little bit unpredictable because atoms can share electrons, but they can also gain or lose, right? They can take electrons or give them up. So when we think about lithium, beryllium, and boron, they have so few that it could go either way. They're kind of like sitting the fence. They could share them, they could give them up if it was easier for them, they could gain them gain more if it's easier for them to get to the 8. Okay, electron affinity is how well an atom attracts and holds electrons, how its energy changes. So affinity, think about if you have an affinity for chocolate, you want it, you desire it, right? The affinity means that an atom is able to attract and hold electrons. Positive affinity means energy must be added in order for the element to take electrons from another element. Negative affinity means the element must give off energy in order to gain electrons. Halogens and most nonmetals are going to have negative affinity. Metals are going to have low affinities, very small positive or negative values. Okay, electronegativity is another key word. It's not the same thing as affinity. It's a little bit different. Electronegativity is more how can an atom attract and hold electrons. So think of electronegativity maybe more of like a bully. A bully can take and hold. They have that strength, right? They don't pick on somebody their own size. They pick on somebody smaller because they know they can hold, that person's lunch money or something, right? Generally higher when the valence level is nearly full. So electronegativity is going to tend to be higher when the valence levels are almost full, right? You have 6 valence electrons, or you have 7. You're so close to that perfect octet, that 8, that you have a strength and a purpose, right? So that's what we're going to see in elements on the periodic table. Electron affinity and electronegativity are related, but they apply to different situations and have different units. Okay, they're similar along the same line, but a little bit different. Okay, we're going to talk about different kinds of bonds. And there's 3 main types that we're going to be looking at in this chapter. The first kind is a covalent bond. Think of covalent bonds as a sharing of electrons. Usually going to be between nonmetals. So typically you're going to find a covalent bond to happen between 2 or more nonmetals. Also, you're going to find that usually this happens when atoms have larger electronegativities, right? They have more ability to take and hold electrons from other elements. So that's covalent bonds in a nutshell. We'll focus more on that in tomorrow's notes. Ionic bonds, the second kind, tend to have a taking or giving away of electrons. Not a sharing, but an actual giving up of electrons and taking of electrons by another element. Usually we're going to find that this happens best between a metal and a nonmetal. We're going to look just a little bit at the fact that it goes back to those valence electrons. I want you to think about valence electrons kind of like this. You have something that someone else needs and you give them up, or you take on, okay? Usually atoms have very different electronegativities, and ions are opposite charges that are going to attract. The third kind that we'll look at are metallic bonds. These involve a sharing of easily lost electrons, usually between metals sharing with metals, usually when atoms have weak electronegativities. Okay, so we're going to take time to end now, and tomorrow I'll pick up talking about covalent bonds.